Good morning, everybody. Today, it's all about open root MIG. Oh, it's hot. Open root MIG is a pretty common process, at least down here in Houston, Texas. Now, it's been some time since I've done this. We're going to start off by learning what happens when you don't properly feather a tie-in and how to properly feather a tie-in, along with fixing your root from incomplete fusion, or as if we just build up too much, get all those whiskers and get too much reinforcement on the back side. Some things in order to make this all work is you got to have the right fit up for it. I've got some 3/8 plate here. I've got a nice long piece, probably close to 2 feet. But the fit up is really nice. We got no mill scale on this plate. We've got a nice wide gap, maybe a little bit wider than I'd like. The wider gap is going to lead to excessive reinforcement if that's going to be the issue. But for what we've got mostly a 5/32 gap and about 3/32 of an inch or so, maybe just a hair under as far as the land. Now, having a nice ergonomic MIG gun is going to really come in pretty crucial for this, with a little bit of a narrow nozzle. I prefer that narrow nozzle for this so that it's easy to get into this V groove as we work it back and forth and start to put this open root in. But now that we know a little bit about what we're going to be doing today, let's jump over to the machine and get everything set up. Today we're going to be using the Everlast Hurricane 220 MTS-C. All these letters on the back end basically stand for MIG, TIG, Stick, Dash, Cutting, because this machine does exactly that. Great machine for someone who just needs one machine to do kind of a little bit of everything in the shop. Today we've got it set up for C25. We've got our 75/25 mixed gas hooked up, turned on. We're good to go there. We've got 70S6 MIG wire 035. We've got our ground hooked up into the negative and our MIG gun into the positive. We're running DC positive for this process. Now, when it comes to our voltage, we're gonna run fairly cold. We're gonna probably start somewhere around 17, maybe even 16.5, for the fact that we have a pretty wide gap and not that thick of a land. We're gonna come way down on this wire feed speed, probably closer to maybe 200. We're gonna start somewhere around 200 and see what happens. And it's been a while since I've done this, and just trying to go off what the fit up is, I'm gonna need a little bit of a colder puddle with not so much wire. As far as inductance, like this machine has in burn back, the burn back doesn't need to be 0.5, 0.2, that's probably good enough. The inductance is a lot like your arc force for stick, but for MIG. If we go up in inductance, we get kind of a crispier puddle, and then if we go down, we get a little bit less of a crispy puddle. I usually run around 70% inductance for like a fillet weld, but being that we've got an open root, I kind of like a nice half and half there, somewhere around 50. Now that we got the machine set up, we got to get suited up, get our welding hood on. We're going to run this pancake hood, and then we're also going to run some Cayman gloves. Everlast, Cayman, Outlaw Leather, these are our partners, so please sure to go check down the description down in the link below. Cayman gloves got a good special right now for their gloves. Outlaw Leather, we've got a discount code for them. Everlast, we've got a code. If you use it, you can get an upgraded foot pedal or TIG torch with your orders. Before we light up, I always like to position myself where I think I'm going to end up and practice the weld joint, as we like to call a dry run. What I usually like to do is I don't position myself too much when it comes to an open root MIG weld, because I actually like to set this nozzle in here and wiggle it. That's one reason why I like a nice tapered nozzle for my root passes. And I'll usually maybe position my hand a little bit on the plate to add some stability and make sure that I'm holding this certain angle. We're gonna go for a nice drag angle, and really we're watching this wire right here. If we're higher up on the weld, the less reinforcement we're gonna get. If we're more in front of it, the more reinforcement we're get, or more penetration. Being that we've got a nice wide gap, we shouldn't have to focus on being too more unless that gap got tighter. We should be able to just try to find that happy medium between not being too far or not being too far in. If we get in a bind, we might go higher up on that puddle if we think that we're getting some excessive reinforcement, because that's likely going to be the hardest thing to do, is prevent heavy reinforcement with such wide gap that we have. Not going to be a problem. We can get our hood on, get suited up, and put a bead in. All right, let's see if we can make some magic happen. My good buddy Scott Robbie would say that you've got 5 seconds to figure out if you're doing something wrong. After that, you're pretty much screwed it up. So let's see if we need to change anything after these first few seconds. And that looks too cold already. So we're gonna go over to our voltage, turn it up a whole volt. We got 17 volts in there now. We'll do a little cleaning here, because that was a nasty start. Trying to stay to the leading edge of that puddle right now. I'm not worried about excessive reinforcement. I'm just making sure that I got kind of a keyhole. I know if I don't make it very far, very quickly, then I know that I'm getting that excessive reinforcement. All right, we're gonna stop and check our progress a little bit. That'll do, that'll do. I think I'll take a little bit more heat and wire though. Sorry I missed that arc shot completely. My big head was in the way. Voltage up, wire up. Starting to feel a little hot now. I want that heat, I want to be able to manage it. Really coming up on that top bevel with gravity and pulling it down to that bottom edge. Definitely working with a bigger keyhole now. Ooh, that was a good time to check on things. Yeah, even caught that tie-in. I thought I was gonna miss that tie-in because I didn't feather it, but it's kind of caught. It's definitely way easier to catch a tie-in with this bigger gap, and turning up the voltage and the wire was able to get that first little tie-in kind of all right without grinding, which is not really heard of when it comes to the short arc MIG, but it does go to show you how important a gap and fit up is in order to make a nice easy weld. But this time we're gonna miss this tie-in. I'm just gonna bridge it, just completely miss it. No way I hit that one. And then move back to our motion. Trying to keep it tight, but if I notice I'm not moving, I'm gonna go higher up on that top bevel so that that wire can catch up, fill in what I need, and not point too much right in the middle where I'm gonna be putting some heavy reinforcement. But I do wanna see that little bit of a keyhole. I'm gonna try to look over top of this nozzle instead of behind it where I normally would, so you guys can see. Feathering your tie-ins are always gonna be a better option. So we'll see what feathering a tie-in will look like in order to, prevent having this nasty miss on the back. Now pretty much the guaranteed way to hit that tie-in, and I know on the first one we got it pretty okay, but the second one we definitely missed it. We've got the low spot, we've got incomplete fusion, so we've got to grab ourselves a grinder. For really any type of root repair, I usually will go for an 1/8 inch wide grinding disc. This one is one of those 1/4 inch grinding discs. It has been used a little bit, so it does have a little bit of a taper on it, which will end up working out for us. Having this large hump right here will keep us from getting that tie-in right on the edge, and we'll end up leaving that little low spot almost every single time. We talked about having that wider gap will help, but really ultimately feathering this is going to be the best bet. The short circuit process is pretty cold. We're going to feather it back quite a ways and make a lot of it really thin. I would say we tapered back a solid 3/4 of an inch, and you can see there towards the very edge we've got a nice thin blue. I usually like to see quite a bit of that blue. We don't want to get too carried away. The only reason why it's blue is because we're pushing heat into it, and if we're just tapping it, you're not going to see a lot of that. And with this 1/4 inch grinding disc, the reason why I don't like using them is because you're going to take away a lot of your bevel walls, dishing those out in order to reach that edge. So don't really get too crazy with that, but we want a nice long taper so we can start way back here, get that cold short circuit process nice and started. That way by the time we work into this thin stuff, it's already nice and warmed up. We've got a nice established puddle, and it breaks away that thin little bit of weld, and then we can move on like nothing happened. With that nice tapered tie-in, we should be able to just keep our normal motion and not have to change anything, and just run right over that nice thin spot. Yeah, it's starting to get a little tight on the back side, and we're not going to end up breaking it open, so I'll show you how we go about fixing that. Now I'm not going to lie, I know I missed that arc shot again, but we did get the tie-in. The bad part is that it's starting to close up, which is real typical when you got a long weld joint like this. Usually as things start to heat up and cool off, towards the end things will get a little tighter. So we're getting a better arc shot of this tie-in. And we're also going to switch over to a cutoff wheel, because what we're going to end up doing with this cutoff wheel is just slightly opening this. Now being that we're in the 2G position, what I'm going to do is open just the bottom. I'm going to try to leave the top alone and that land alone, because gravity is going to work against me and I can always hang on to the high point, but when I pull things down I want it to tie in properly, so I don't want too heavy of a land on the bottom. So I'm going to go ahead and work back. This is what's known as either called ripping it open. It usually means you're trying to make the gap wider, or softening the bevels, where we're taking away some of the land or some of the wall thickness so that the bevels are easier to punch through. So that's what we ended up doing, just something along the back side. We got a nice taper here. I'm even gonna go a little extra mile. Make sure we have a quality blend into here. I'm gonna show you how to fix that mist tie-in, and we're gonna get too crazy with the wire back here, and I'm gonna show you how we fix that. Definitely easier to break down those softer bevels on that tie-in. Now I'm gonna try to get too crazy with that reinforcement. Start getting too far in front of it, like I know a lot of you probably do, and throw a bunch of those whiskers in there. So now that we know we put some whiskers on the back side, before we finish this up, let's see if we can fix that. I guess you just gotta lock me away because I missed that arc shot again. The point was to try to show you that softening the bevel will get the bead in. We were able to get the bead in, clean tie-in, and then we started putting those whiskers in. Now I know a lot of y'all have that issue where you jump forward and you start putting those whiskers in. As soon as you know you pop 1 or 2 in, stop what you're doing. Stop immediately. Do not keep welding just because it starts going smooth. Those whiskers are still on the back. So now we're gonna fix those. And again, it really just comes down to just some creative grinding. Now I can tell you those whiskers go back at least 1 inch. So think of it as if you were just doing your tie-in taper. I'm gonna put a little bit more energy into that one because we know that we've got those whiskers back there. And then we're gonna switch over to this cutoff wheel. You guessed it, we're gonna zip right on through the middle. The cut is all the way back to those, that last whisker. I'm gonna go a little bit further, and now we're gonna shape this bevel as if nothing was there in the first place. So we're gonna go back to our grinder, because we're gonna need to taper back a lot farther. We're even gonna do a little bit of that bevel softening because of that cutoff wheel that went in there. It's not gonna be the most ideal bevel to weld over top of, but it's definitely gonna fix those whiskers. We'll get that cutoff wheel in there again and just shape it. Now the hardest part about this is making sure that you deburr it, where there's no whiskers or metal burrs on the backside that you're not going to consume. Now at this point you're probably going to want to get some sort of a special tool. I've got a little deburring tool. If you have access to the back of it, it's not an issue. Just get back there with a wire wheel or something to clean it. We don't know if this is going to be x-rayed or not, and if it is, we want to deburr it and get any of those wires that we can reach, because if those wires are still there when we're done trying to fix it, then we didn't fix anything. It's still got wires, and that's going to show up. So we want to make sure we deburr everything. Still, we got that taper. Essentially the entire whiskery area was removed. That's why it's important to stop when you're starting to get them, so that you can fix them now, because they're really hard to fix if you've got a full root in. Now let's see if we can get an arc shot of this tie-in. It really isn't much different than what you see here. And the trick is just to make sure you've got a good taper and staying on top of that puddle, but at the same time at the leading edge. You definitely don't want to have to grind things out again, because if you have to fix things and fix things and fix things, it usually never ends up being very nice. The bevel tends to get a little bit chewed up after a while. Don't have much bevel left anymore to walk on, so we are freehanding it a little bit, which is always an option too. All right, so check it out. Here's our plate. This is the front side, and you can see, of course, all of our tie-ins here. Gonna be pretty common to have a pretty cold start because we start so far behind our tie-in. That's the biggest thing when you're making a tie-in with short circuit MIG, is that you make a really long ramp because of all that. That's that cold start that it has to get out of its system before you tie in. We've got a good tie-in here. Wait, no, right there. That's the tie-in that we just made from the repair. And then that's what it looks like. You see how it's thin and ropey compared to this? That's because that gap started getting a little tight. So we opened it up and we started getting a better bead. But same thing with feathering your tie-in here. It's a good tie-in. Harder to see on the back side, right? And that's what happens when we don't feather it. We've got that fisheye showing. We've got a miss You've got a little piece of cold wire back there. And then this was actually without feathering it. We were still able to catch it because of that wide gap. But now, I'm going to show you how to fix something in the middle of your weld from the front side. At this point, nothing's really changing. We're going to go ahead and grab our grinder. This is that 4.5 inch from Walter, and we're going to go just attack this area. We know where that is. Sometimes it's helpful to mark it out. We know it's pretty much dead right in the middle of that. We're going to end up having to make a repair area about that big in order to get the proper hole that we need and to get the right tie-ins and tapers. It's going to end up being pretty excessive, but we're going to flatten that all out first. We're going to give it a little extra love in the middle compared to the edges of this weld. We know, like right in the middle of that heat affected zone where that stop is, that's where our tie-in is. That's about where we're going to end up having to hit. We're going to have to open this up quite a ways in order to fix that little spot. And if you notice how I'm holding my grinder, it's just so I have a better field of vision of what I'm working on. If you hold the grinder more like this, you have to look over top of it. Something's in the way where you're not seeing properly. So I always like to look across that grinding disc to see what I'm actually working on. We can switch over to this bigger grinder. This is the 6-inch grinder from Walter. This is my dedicated cutoff wheel grinder. I don't need to get carried away and making a big line. I know I've got more than what I got, so now I need to start shaping that bevel. You gotta open that gap up a little bit more. I can't push that 1/4 inch rock in there. That's again one reason why I like an 1/8 inch disc, because it's better for this type of stuff. The important thing is that you take your time with this and shape it as best as possible. It'll never be as good as it once was, but you gotta still get it fixed. I'll even sometimes run a wire wheel through here, deburr a little bit of that area from the front. And then lastly, you go in there with that deburring tool. We know coming off of a weld what it's going to do to react. We want it nice and thin and tapered so when we come off it blows through. We want almost more running into a spot because once it closes up we need it to blend properly. We don't want a low spot, which is the likely thing that usually happens, but if we can avoid it, we will. What we're going to end up doing is weld, weld, weld. Right when we get to that tie-in, it needs to be nice and thin, and then we're going to change that gun angle and make sure that we blend it in and taper out. And now we just do what we know. Just start way up here on the ramp, come into it. It should break down pretty quick from our grinding. Should be on metal now. Now we make sure we just bridge that gap. It's probably going to get pretty hairy. Might have to go pretty wide. Oh my gosh. Overgrind, overgrind. It's really easy to mess up that repair, and that's what we gone and done it. But you'll take care of this just like you would those wires. Just grind it out. All that excessive stuff, it has to get removed. It can't be heavy. Not an easy fix. Definitely more grinding than I intended on doing today. Those are probably the worst to remove because you've got to think of it as like, where is that big heavy spot stuck to? Well, it's stuck to the freaking plate, so that removes a lot of metal. And yup. What do you do now? We turn it down. We got our voltage at 18. We're going to turn that voltage down to 17. We're going to keep the wire the same and see if that helps. Golly, big problem. Let's see if we can't make this worse. Oh, it's so cold. Just gotta keep it lit. Oh, where's the bevel? That's not it. Good golly. Oh look, I magically can get on the back now. You fix it? Not really. Not really. Well, it's definitely tied in, but it's a little bit heavy, and that took some time, and we kind of had to get to the back of it. I wouldn't necessarily say that we cheated, but you're really at the mercy of your code at this point. If you're able to get to the back and do a little grinding, it's really not a problem. All you're going to end up doing is just grinding the back of that weld down a little bit to make it match the rest of it, and then you're kind of good to go. If you can't reach it, then you're at the mercy of the non-destructive testing method they're choosing to do to test it, to see whether it comes back a little bit too heavy. If you're allowed to blend it, blend it. If it's too heavy, then now you got to do what we've done a few times already and cut it back out and fix it, which hasn't really been the solution. If this was something that was happening often on the job site, or this was an issue, I'd ask if I can switch a process and maybe weld it with something I'm more familiar with. Practicing your tie-ins and practicing your open roots, every time you get done with the root, check it. If there's anything you can fix, go ahead and try to fix it, especially while you're in school. It's only good practice, because when it does happen in the field, you never know just how bad it's going to be or how many times you have to go about fixing it. Let us know in the comments if you liked it, or if there's anything else with your MIG open roots that you'd like to know a little bit more about. And as always, everyone, thanks for watching the channel. We'll see you guys on the next weld. Lord, if I don't get some kind of arc shot here, lock me in YouTube prison. I need to move my big melon out of the way of this camera. Way the heck over here. I know you're not dead. I think that camera died.